With that, I'm going to be calling our first technical presenter, which is Hans Reinders of Oxycom, the CEO of Oxycom. Of course, you have 20 minutes.
I will not take 20 minutes. I'll try to keep it shorter. Okay, let's start. This is my basic message. The message is clear. The world is going to change. The industry is going to change, even if we did it for 50 or 60 years, one way or another. There's no way we can stop this. Humanity deserves a future. There are many new technologies. I have a list from NREL, an American university, that there are about 15 new technologies emerging. Most technologies are not known to most people in the industry because we're all focusing in on what we know and what we do. But there are definitely technologies emerging, not always available, but soon they will. Sorry. My issue is using water, that's clear.
What can we do about that?
4 kilowatt makes 1,000 liters of water, and 1,000 liters of water gives you 700 real kilowatts of cooling power. I can read it here. Well, these figures, you know, they go into your ear and they go out of your ear. It's staggering. We will come later on to the situation in Saudi. Dramatic situations are coming up. The country cannot sustain cooling capacity because simply the use of oil is so big that they will not be able to export anymore. It will explode tenfold. See the young generations coming up, especially in the Middle East. There's building going on everywhere, a young population growing fast. We'll have to cope with that. This is the situation in Saudi. This comes from a report that is called the hidden oil crisis, burning oil to keep cool. And what you see here, I don't think the light is it is all too clear, but, oh, one moment. Here is I don't know if you can see it, but there's a blue line going up here, which is not clear to me. I hope you can see it. That is the amount of oil they are going to need to fulfill the cooling needs in the near future. Come on, back. This is an issue because that means social unrest. How the hell can we keep everybody happy if the main source of income of a country is disappearing? And that's not only for Saudi, that is basically happening in many regions. This is a very interesting report. I can recommend it to all of you. It's the hidden oil crisis, burning oil to cool. This we see a lot. We see all kinds of initiatives. But what I've seen here in the last 2 days is, and I'm a technical guy, you know, if someone says, yeah, you can do it this way, someone else says, oh, no, but I can do a little bit that. You're not right. It has to be this way or that way. So there has to be far more unity in working together, not saying you're not right or you. Let's please take advice from each other, listen well. And if I make a remark here that is of use to my biggest competitor, I don't care. Because together you develop the market. If one wants to change the market, like us for instance, we will fail. Because the rest of the industry is diminishing it, is trying to push it down. We need each other. That is our strategy as a company. We have decided that we go for OEMs, that we want to supply to the whole industry to have maximum impact. Maximum impact for the environment, and of course it's good for shareholders. But that is a necessity, otherwise nobody comes up with ideas or brings his money on the table with a great risk. Shareholders have to be valued, but the environment is the most important matter in this whole case. These are some new technologies. Magnetic caloric, it's already in the market. Beautiful technology, mostly used in dispensers for Coca-Cola and Fanta and that stuff. There are some others, the duplex Stirling heat pump, very expensive, very efficient if you can use the heat. And this is only 5 of the 15. We have 5 of the 15 most promising technologies in our portfolio. The one I'm going to talk about here for short, because it should not be commercial, I was told, is advanced evaporative cooling. It's available, it's widely applicable, and it can help you tomorrow to change your energy use. Every hotel here could decide tomorrow to save 25% within the coming month. That's amazing. We're talking about a business and industry that's used to component efficiency increases of 1, 2, 3%. We have to talk about 25, 50%. Otherwise, in 10 years, we have a major issue, as you saw before. Yeah, there I come again with my water. At least I hope when you all go home, you jump in your bathtub with about 1 cubic meter of water, and you will think, hey, this could have been 695 kilowatts of cooling power. We all use water to cool. It's as simple and as effective. There's nothing more effective than water. Well, this is basically the circle that we talk about. 4 kilowatts of electricity, only using 0.08 ton of CO2, produces 1 cubic meter of water and creates 695 kilowatts of cooling power. If we do that the traditional way, we also need about 1 cubic meter of water. If I say 0.6, I'm talking about very efficient. If I'm talking about 1 cubic meter, so then I'm talking about an average use of water to produce 1 kilowatt of energy, or in this case, 250 kilowatts of energy. So you go with similar use to this type of oil burning activities to create 695 kilowatt of cooling. Well, if it's so logic, why don't we all try to use this? There are disadvantages. We have to change the way we handle the water that is going back into the ocean, I'm sure. But if we can't solve that, I would be amazed. This is a bit too long, so I'll skip it, but I'll try to skip it. It basically talks about our product, but I don't want you to take all the time to read it. This is basically what is our material. It's an aluminium. We discovered heat exchangers are always made of flat plates, so your air stream is sticking to the wall and becomes laminar. A shark doesn't have a laminar skin. A shark has a skin that's disruptive, that changes the airflows. That's why it can swim hard. So we made a material that is aluminium covered on both sides with a coating that can absorb water and evaporate from the skin. Over 90 millimeters in a Jeddah condition or in a Riyadh condition, we go from 48 degrees to 26 degrees. And we reach 92% efficiency, and we have a pressure drop of around 25 Pascal. Let me tell you something else. 1 square meter of this material at a speed of 3 meters per second can deliver 67 kilowatt of cooling power. 1 square meter of evaporative material can deliver 67 kilowatts of cooling power. In this area, it would be about half. This is one we are installing, so we have to take the risk of being captured by promising a lot and failing. So we are now installing this one at Al Maktoum Airport. We will have 2 buildings to prove the technology, and it will be monitored for a while. And this one is a unit that I don't have a picture from, but is by one of the major suppliers in Saudi that has tested the direct evaporation technology to pre-cool the incoming air, and there I talked about from 48 to 26 degrees Celsius in just 90 millimeters. This is a unit that's on the roof in Germany. I got a picture 4 days ago, it was 32 degrees, and the ingoing temperature to the chiller was 16. I don't know the humidity, but it must have been pretty low. This is probably, I'm talking about something that you all know better than I. But if you know that 1 degree Celsius gives you 3.5% efficiency, then I think this is the only way to go. I mean, which component can give me so easily 3.5% efficiency per degree? It's amazing. In Jeddah, this will happen at 10.2. This is the design norm that you use in Saudi, in KSA, 46, 10.2 gram. We will go to 26, and we have electricity saving of 48%. Of course, I need water. But I don't, if I take water, I don't produce the CO2 that you would have needed, that you normally would have needed if you would take this this air coming into the unit. So my CO2 reduction is half. In Dubai, it might only go at the design condition from 39 to 30. But that's still over the whole year, and I'm taking the design condition of 1 day, but the calculation we made is over the whole year. Over the whole year, a typical chiller here would save 27%. Now the trick is to make it simple, to just click it on and not be afraid of the pressure drop. If that's the case, you can't use it. These technologies have been used before. There are paper pads, there is spraying in the air. It's simple. It has to be durable, it has to have no pressure drop, and then you can achieve these staggering savings. This is a wall that we made for a data center in Holland. The data center was using 560 kilowatt hours in electricity. We brought it back with 8 of these walls to 25.6 kilogram. And simple. It was an indirect situation, so what they did, after the cooling wall, they used counterflow heat exchangers with a high efficiency so that the indoor air and the outdoor air were not touching each other. Very simple, very efficient, and very durable. And no maintenance. So here you see the 1 square meter of this material and the cooling power. This was, I have to be honest, at a velocity of 3 meters. We can go to 3 meters, the pressure drop will increase, but it's still nothing. If you go to 3 meters, that will happen. We have no droplet liftoff coming from the evaporative material, which is of course important, even at 3 meters a second. This is one of the last pictures. This is a product we designed for Australian homes. The issue was noise on the roof, totally different from all the other aspects. Noise on the roof, disturbance of the horizon, neighbors that are complaining, so it had to go under the roof. And we designed with the same material a unit that pulls in air from under the roof and brings it via 4 fans to 4 individual rooms, and you can control it. Basically 4 evaporative cooler in 1 unit. You don't hear the unit from outside, and inside it's absolutely silent. This is my takeaway point. The world is going to change. And I hope that is, if we all understand that it has to change and it's going to change, we better look around on our back who's going faster. Who's going to change it? Because if the government increases the demand on efficiency, the industry has to follow or you're out. And I tell you, we are very innovative altogether, sometimes a bit lazy, because we have to, you know, here we are in a market where demand is huge. So we're all selling and we're working day-to-day hard, and we look at our P&L, we make money. But if we don't change, someone will do it now. I am convinced. Thank you.
Hans, just if you can just stay on stage in case there are any questions. Any questions for Hans, please? Yes, Chris Rajamani.
Wonderful, Mr. Hans. You stressed on the point of energy, right? There was one more point I need to stress on to the audience here was about water. Water is also a very precious resource here.
Sorry?
Water is also a precious resource in this part of the world, yeah? On your 4th slide, you mentioned grey water. For the use, should.
Could or should.
Should, yeah. Why I'm getting this point across is here, we have still a lot of companies who have the grey water available for evaporative condensers, domestic users, etc. But we are still not using it completely, all right? So this could be one avenue where, we could save energy, we could save power costs, etc. Coming from a laboratory background, I'm just interested to know what quality of maybe grey water or seawater or potable water, maybe the pH or the TDS, what type of water is, applicable for your type of condensers?
Well, we have no experience with grey water, but we understand that it is an issue here. So we started working on that to understand what's the issue and how far do we have to go so that we can make decentral, small units that accept the grey water and confirm it to the water that can be used. I don't think it's a burden for us. It would only be a next step of being more happy. If you can produce 1,000 liters of potable water with 4 kilowatts and create 700 kilowatt of cooling power, then grey water is nice, but not necessary in my opinion.
If you replace potable water with grey water, you're talking about a lot of savings here, right? Mm-hmm. Am I right or wrong?
Sorry?
I mean, if we replace potable water, if you're going to use potable water for your equipment and we replace it with grey water, which is nearly potable standards, yeah, with regards to the chemistry. I know microbiology is going to be a little critical.
We have, I don't have everything in my mind, but
yeah.
If you go to my stand, we have brochures about the technology. And if you go to our website, we describe exactly what the mineral content or what the quality should be and where we guarantee and where we don't guarantee, how often you have to bleed off. These things are all known to us, but I don't have them in my mind.
In your opinion, it is possible, right?
Oh, absolutely.
That's what I'm after. That's what I need to get across to the audience today.
We have a 10-year experience with the material, so it's not just coming to market. That's very important.
Thank you very much.
Thank you.
Okay, can take one more question. Yes, Saad.
Thanks, Hans. Just a question, obviously. I've got one comment and 2 questions, if you don't mind. I think this technology is wonderful, but I think you're going to struggle convincing the market because obviously I wanted to see more of the humidity achieved with the 30 degrees Celsius. I don't think 30 degrees Celsius is comfortable.
I cannot hear you. Sorry.
I don't think that 30 degrees Celsius is comfortable. I think
no.
You need to show. Let me just finish. You need to show the relative humidity with it. That's one point. The other point is how would you be able to control the Legionnaires disease? Because obviously you're transmitting water, and with the 3 meters per second, you could transmit water with Legionnaires. So, do you have any chemicals in the water?
No, we use.
And how you will be able to control that? And I think your technology will be very good for industrial use. You could, if you improve on it, maybe you will go to the hotels and so on. That's my comment.
Basically, what I talk about is evaporative cooling. So we all think now it is only direct evaporative. But the main product we have had nothing to do with direct evaporation. It has to do with indirect evaporation. It's a heat exchanger. It has a width of 200 millimeter counterflow. And over this 200 millimeters, I can easily go to the dew point from any temperature without increasing humidity. So if I can go from 60 degrees to 17 or 20 or 22, I'm very close to the temperature I need. I don't need the lowest temperature in the world because we ventilate 5 times per hour. So we have comfort that comes from cold air and from air that is cold, that gives you a chill factor. This is, if you look at building designs and air conditioners, they should be designed in such a way that in the morning the temperature is lower and during the day it can go up with the outside temperature in Europe. Here, quality of life means cold air every moment. To receive that, you use the indirect evaporative cooler together with a chiller. You use the outgoing air by humidifying it to pre-cool the incoming air. That means the temperatures of the incoming air go from 45 to 20 because the outgoing air, humidified, cools it down. And then the air is ready to go over the condenser, no, over the evaporator, into the building, and it only has to do a little bit of dehumidification or drying. The exhaust air that has been cooling down the incoming air is then used to cool the condenser, because it's very useful air with a lot of energy still to be put in. And if you do that, we can ventilate 5-6 times per hour. We need to ventilate. If we wouldn't do it, it wouldn't work. So we can ventilate a school or an office or a hotel or a hospital 6 times per hour and save 60% compared to using a traditional technology without ventilation. And then the issue is more, is that the only technology? Can we only use it combined with an AC? I think the industry would love it, because we are all living from selling the technology that we have today. So a combination could make both our lives better and the life of the end user. But there are new technologies. There is a heat wheel that I talked about that absorbs humidity and releases it with 50, 60 degrees. So I can pick up humidity, 4 or 5 grams per cycle. We did a development together with CSIRO in Australia. It has also been advised to the King Abdullah Care movement, or whatever you want to call it. We used a drying wheel that absorbs humidity. We use a solar collector and an oxy cell. And we have set point cooling, and we would save 60 to 70% energy. But there are so many ways to go. But mostly, the combination with a water-driven technology is necessary because water is so powerful. Thank you.
Excuse me, I have a question, please. Hello?
Yeah,
Yes, could you please identify yourself?
Okay, my name is Numair Alamdar. Really, it's an impressive product. Thanks for your introduction. I have one question, please. You mentioned that you have 2 cases. One is in Jeddah and one is in Dubai. And both, as I understand, that you are installing for air-cooled. Okay. I noticed that the electricity saving in Jeddah was 48%, and in Dubai is 27%.
On a year basis.
Yes. So what is the reason? Because I understand that Jeddah is mostly similar to Dubai. So
You want to say something, Khaleb?
No, they are not. Jeddah on the coast, yes, and Dubai is in the coast, yes, but the Gulf, Arabian Gulf is so small that it becomes like a stagnant pool with no air movement, and thus the relative humidity in Dubai is much higher than that in Jeddah at the same dry bulb ambient, because the Red Sea is quite big. And there are waves and air to carry out that. The system efficiency and production was based on using psychometric chart, using both dry bulb and instantaneous with bulb temperature. And those have a special computer program which calculates the profile of temperature with bulb and dry bulb through 876 hours a year. This is why we are giving you the truth, how it happened, and how it is going to be.
By the way, if you would like to check on this, on our website, if you go to Oxycom and you go to the selector tells you the design conditions in every city in the world. And if you go there, you can fill in your needs or the circumstances, and it will print you a report, and we will know that you've done it, but that's all. And it's an easy tool for your own calculations, perhaps in other cases. Please visit the selector, and you will find what the technology does. Thank you.
Thank you, Hans. A warm round of applause for Hans.
Thank you.
Shall call the